Hello and welcome to the inaugural OpenSignal podcast. I'm Samuel Johnston.
And I'm James Robinson. So this is going to be a series of conversations that we'll be filming here in OpenSignal's headquarters in London. And we're going to be talking about lots of different topics. So things that are close to our hearts, like mobile networks and how well they're performing, the huge variety of Android devices that are out there in the wild, all the sorts of different things that you can do with data. And this week we're going to be talking about something that's very dear to us indeed. So Samuel, what's the topic?
Today we're going to be talking about mobile sensor networks. So James and I have just published a paper entitled Mobile Sensor Networks Creating a Social Laboratory, which takes a look at how mobile phones are increasingly becoming part of the Internet of Things, a network of sensors kind of constantly on and constantly on people, collecting data about the world that can be tapped into by developers and scientific projects. And so we'll be tracing the history of the sensor, tracing the history of the sensor network from 15th century career up till now, and generally going on a few detours along the way.
So what does it mean to talk about mobile phones as part of the Internet of Things?
Well, I think a good starting point is to think of mobile phones as a sort of a bunch of connected sensors, basically. So you've got all these sensors that just happen very conveniently to be packaged together, so they're one point together. They've got a GPS with them generally, and they're connected. So they've got a cell or a Wi-Fi radio. So this is just...
just to kind of stop you there, I think sensors in mobile phones is not something people have ever really thought about before necessarily.
Right.
A lot of people, when I tell them that their iPhone has a barometer in, if they have a kind of iPhone 6, kind of get very surprised and ask kind of what's that doing there. So I think before we get into too much kind of discussion about the sensors in mobile phones, it's good to kind of say that actually that your mobile phone has a lot of sensors that you may not know about. It has a light meter which is used for adjusting screen brightness. In many cases, a barometer which is used to get a more accurate GPS fix. So increasingly as our devices get smarter, they contain more sensors that are capable of telling you information about the outside world.
I think it's worth. I mean, the barometer, for instance, it's you might think, well, how does that help you get a bit of GPS fix? It's just worth noting that the barometer, your pressure gets lower as you go higher up.
Yeah.
So if you want a sort of three-dimensional GPS fix, you need a lock on several satellites. You basically, if you have a barometer, you don't need a lock on as many because you can get the height information using the barometer. So that's just one example of how something quite specialist a barometer gets into a device. And then of course the accelerometer is maybe easier to imagine that you're playing games, your screen is sort of rotating and the accelerometer that's doing that. But,
and also, when your screen turns off, your phone turns off its screen when you put it to your ear. I mean, again, that is accelerometer at work. Yeah. So all these things, all these really seemingly magical features of your phone, it's knowing when it's going to flip around, even though quite often it's very annoying when your phone wants to flip around, are all created by having sensors in mobile phones.
And I mean, actually, we're overlooking perhaps the most obvious and basic and perhaps important sensors in a phone, which are, you've got the cell radio, and that's essentially sensing the cells that are
if there's a presence of a mobile phone signal.
Exactly, and how strong it is. So actually that's that's key to what we do. So we're building maps of
handy graphic. So,
maps of signal strength, maps of cell towers, and that's all based on a crowdsourced sensor network, our users contributing data.
So I mean, the reason we are sat in front of you is because we have recently published, as I mentioned at the beginning, a report on mobile sensor networks, but we've also published a kind of regularly updating library to inform developers about the prevalence of sensors worldwide. So you can now, there's no other real resource of this information available. So, but now if you're a developer wanting to build, say, an app which, relies on barometric pressure, you can now go onto our website and see that 26% of global Android phones, I think that's the right number, have a barometer in, and that will tell you whether there's the market there for that device. I mean, because recently the Galaxy S5 had a temperature sensor in, which Galaxy S4 rather, Galaxy S4 had a temperature sensor in, which fantastic. You can make a thermometer app, but has now been discontinued. The S5 doesn't have it. And so you can use our website to find out how many phones would have an ambient thermometer.
I mean, we include a lot of things as sensors. So Bluetooth for us is a sensor because, again, it's a radio use Bluetooth.
I mean, well, that's...
Same for Bluetooth Low Energy. So
that's an interesting point, James. What is a sensor?
Well, yeah. Well, that is a very good question. Let me finish my point on Bluetooth Low Energy first. Because I think it's something that's another thing that people might want to look up. Like, there's a lot of apps that might be relying on Bluetooth Low Energy for communication. And what is the penetration? Well, I can't remember off the top of my head, but it's in the sensor library. So
yeah, sure. So go and check it out.
But yeah, what is a sensor? And I sort of managed to dodge that question and give myself a little bit of time.
Tried, but then he kind of shot himself in the foot by coming back to it.
I think it's something which takes a piece of external data, external facts about the world, property of the world, and converts it into, well, generally quantifies it.
It turns it into data.
Yeah.
Is that what you're saying?
Exactly. And the quantification can be very rough because, sensors can vary in their accuracy. You can just have something that says, well, I don't know.
Well, they can be binary. I mean, so you, in the paper, you use you always kind of deliberately try and throw the reader off a bit by throwing them examples they might not have thought about to kind of illustrate how common sensors are. And so the one I really liked was the doorbell. This property, is your guest there or are they not there? And you can tell that by whether they're kind of pressing on the doorbell or not, which I thought was quite nice. And that only returns kind of a 0 and a 1 as values. Yeah. And that was very good.
Oh, thank you.
So yeah, I mean...
Bigger question.
Sure.
What is a sensor network?
Right, yes. So a sensor network is, I mean, it's almost what it sounds like. It's a way of recording data about the world using a network of sensors. So my definition is a sensor network is a network of sensors. So I hope that's useful. But it's a way of collecting data from sensors and recording it centrally in order to basically gain better information about the world. Often used in mapping is one kind of early example. And there are some, they're not new. I mean, so we talk about the mobile sensor network. Right. But the sensor network has an incredibly rich history, almost as rich as the sensor itself. I mean, you need to know all sorts of things from a sensor, like whether your compass is pointing north, what direction the wind's blowing, say, if you're a sailor. But it's only once you start collecting this information that it then becomes useful to other people, once it's been logged, which is a key kind of development. Once you have sensors logging their information, and that logged information being used centrally, you have a sensor network.
Right, okay, so I think this is an important point there. Sensor networks are not something new. They're not about mobile phones. They've got, as you say, a very rich history. So, I mean, maybe it's worth talking about some of the earliest ones. You hinted at one there, which I think is
well, we are, James and I have got very into this topic over over the last few months. The sensor network has been around for a long time, as you said, and I think James claims to have discovered, well, not discovered, but James seems to have identified the oldest sensor network known to man.
Well, in my opinion, and I'd really love to hear if anyone knows of anything that's older, but I think the first sensor network was a Korean rain gauge network. This rain gauge was called the Chaegugi, and it was in operation from the 1400s. So this rain gauge it was essentially a bucket.
Sure. Yeah.
A bucket that was placed all over.
Shows you how simple sensors can be.
It was mandated by the emperor at the time that there should be these Chaegugi all over the country, these buckets. They collected rainwater, and that was a very simple mechanism for turning the data, amount of rainfall, into or the fact about the world, amount of rainfall, into a piece of data, presumably the depth of water in the bucket.
That's very. I mean, it's very interesting, fascinating. But what did they do with that data?
Right. Why did the emperor bother?
I mean, presumably they weren't, doing kind of complex rain mapping forecasts in 15th century Korea.
Well,
or maybe they were. I don't know.
I'd like to. What we know they did with it is that they used it as a basis for setting tax more fairly, because obviously if you're getting more rain, rain is highly correlated with agricultural performance. Too much
rain, fertility of land.
Exactly.
Okay.
So the emperor's idea was, let's just measure this and let's see if if I'm overtaxing in some places and undertaxing in others. So it's kind of interesting in many ways. The simplicity of the project in terms of the equipment, and yet on the other hand, the complexity in terms of sending these rain gauges all over the empire, gathering the data back centrally, and having basically accountants look at it and trying to understand
what it means.
Yeah, what it means.
Yeah.
And one other sort of historical side note, and you're smiling because you know what's going on. That I want to throw out here is that interestingly, the Shegu was invented by a peasant called Yang Seal. So it was a time when it was actually quite possible for able or very clever peasants, if they got lucky, they could come to court and contribute ideas. And this Yang Seal, he came up with his invention. It became was immensely successful. Unfortunately, other of his inventions didn't do so well. He invented or designed a sedan chair for the emperor, and it broke while carrying the emperor.
Probably not the best idea, I'm guessing.
Yeah, and he got in lots of trouble. So
what kind of trouble? Fatal trouble? Or
I'm trying to remember. He was definitely in prison.
Right.
And I don't think he was executed for it, but he was certainly in prison. We'll have to read our own paper.
Reread our own paper. Yeah. I think, that's a very interesting point. I think that's something we're going to come back to, this idea of kind of meritocracy and sensor networks. I think is very exciting. But I think as I've let James kind of geek out for a little bit, it's probably probably my turn. So, as James says, the Chogugi, is that how I say that right? Chogugi?
I have no idea.
Right, okay, maybe don't trust our pronunciation on that. The Chogugi network is kind of a great early example of this. But there are for me, the closest kind of traditional historical sensor network that is analogous to what we're doing in mobiles is fleets of ships, which were kind of like people are today, kind of roving around the world, carrying with them sensors that were constantly logging information. So ships, and that's where the word logbook comes from. It's where you would log the events of the day, and the development of mobile sensors, sensors and weather forecasts.
Well, they were mobile sensors.
Well, I suppose that is true. And I think that's why it's so nice. Moving around.
So let's get a solid idea of this. Whose ships were these? When was this happening? And what data was being collected?
Yeah, it's a good question. So it's kind of easy to think of these things as just, so ships were a sensor network. But I think it's very good to make kind of concrete examples. So, many of the kind of great early contributors to meteorology were ship's captains who collected, who recorded kind of information. Robert Fitzroy, Francis Beaufort.
Fitzroy, right? So he was on the captain of the Beagle.
Yeah, that's correct.
That right? Yeah,
kept great logs of. And Jan, you know quite a lot of this. Great logs of the weather and.
Yeah.
What was his great contribution?
Well, it's interesting because Fitzroy, his career went down sort of various different blind alleys, let's say. So, for one thing, he was
a huge Christian, wasn't he?
Yeah, he challenged Darwin famously.
Regretted taking him around the world.
Exactly.
Yeah.
Challenged Darwin, but he, on the other hand, he did take Darwin out to the Galapagos Islands. Another thing, perhaps his greatest contribution, I suppose, is that he was the first director or the head of the Met Office in the UK.
Yeah.
So he did that, which was great. On the other hand, one of the things that he did there was he sort of promoted his own sensor network of what they called the storm glass. That was it. He built this thing called storm glass.
Sounds like something out of a kind of Philip Pullman novel.
Yeah, so this is a bit of an aside, but this is really interesting. So he built this thing called the storm glass, very Philip Pullman, and not only in how it sounds, but it looks sort of magical. A piece of glass that would sometimes go misty, quite white, like a cloud of white.
Was this based on any hard science at all?
Well, he thought it was scientific, and he thought it was like a really good indicator of when there was going to be a storm.
Right. It sounds like a really good indicator of whether glass is foggy or not.
It's
basically
it's brilliant at that.
Yeah.
But and so he had these storm glasses sent out all over the country, and actually he was using the telegraph to bring to collect the data.
And you actually have you quote Catherine Anderson.
Yeah.
In our paper, there's a very beautiful kind of phrase saying that the development of the telegraph was very important for meteorology because it was the first time that news of the winds could travel faster than the winds themselves. Yeah. Which I always thought was very kind of beautifully phrased.
Yeah, I think that's. I mean, I'll just finish. That's a great link back into the ships, which we should get back to after this kind of
crazy tangent,
long detour talking about Fitzroy. But I mean, just to clarify, the storm
glass was
was another blind alley. It doesn't work. Sure. Although you can still buy them today in some camping stores.
Well, good. I wouldn't want to go camping with someone who's relying on that for their forecasting. But as you say, he still had a great kind of contribution to history meteorology. And another captain you may have heard of is Francis Beaufort, who lent his name to the Beaufort scale, which we still use for kind of force 7 is gale force winds. Yeah. We still use that for kind of judging wind speed, which is obviously very important still on sailing. And I think that is...
and where was the Beaufort? Was this one of the things that was routinely collected in ships?
Wind speed was, and wind direction was collected. But just kind of very briefly, before we go into that a little bit more, is that, I think this is why ships' captains have been so important in the history of meteorology and in the history of sensor networks. Because the sense is, when you're at sea, the weather is a matter of life and death to you and to everyone else. So kind of recording it, there's this kind of great kind of brotherhood of the sea almost. So, the reason you logged information about where bad storms were is because it could help keep other people like you alive.
Right.
But anyway, so yes, coming back to the sensor network. Ships' captains would keep logs of the wind direction based on a very simple sensor, a flag, which tells you which direction the wind's going in. And this was then turned into... Sorry, you were going to say something?
I was just going to say, no, it sounds like you were just going to bring it up, but what did they do with this data?
So I think 1686, Edmund Halley was given access to the logbooks of the British Navy. And from this, he created a map, thought to be the first meteorological map, actually, called the Map of Tradewinds, which just kind of shows you across the Earth the kind of general direction of where the winds were going to allow you prevailing winds, allowing you to sail, where you could sail across the Atlantic.
Obviously, incredibly important to navigation,
and also incredibly important to the slave trade, which was obviously
So again,
the checkered past of the history of meteorology.
Right. And Edmund Halley, of course, the same as
Halley's Comet, exactly. So really, kind of a kind of polymath you don't really get anymore.
Yeah.
But the other example, so that's kind of a very famous example, but to kind of prove this kind of goes beyond just kind of pure meteorology and beyond Britain, is that the Dutch East India Company, kind of one of the great naval fleets of the 18th century, one of the great commercial fleets of the 18th century, also kept logs. One thing they recorded was magnetic declination, which is the amount that true north differs from magnetic north. Obviously, a compass points you towards the magnetic pole, and that varies quite a lot.
So how do they work that out?
Well, obviously, you have reference to the North Star.
Okay.
So actually, it wasn't the Dutch fleet that originally started doing this. It was Iberian sailors in the 16th century who first noticed that their compass wasn't necessarily pointing to what they would consider to be north.
Right.
They started taking note of it.
Which is pretty worrying when...
Well, yeah, especially if you're sailing at night in a storm and you know that you need to go due north to make it through a passage or whatever.
Yeah.
Not being able to rely on your compass. And, because actually the compass was often your only guide when sailing at night, in a cloudy night, or, when there's and it's in the middle of the ocean with no other landmarks around, the compass becomes the sensor on which you rely.
Right. I suppose, before the invention of the, what would you call it, the chronological... watch.
Yes, the ship's watch.
It was also the only thing you could, during the day, you had no way of working out which way north was, apart from a compass.
So knowing kind of where you're sailing is quite an important part of sailing, I would say.
I'm not an expert.
No, I'm not an expert, but it sounds quite important. It's definitely important for walking. again, this happened in the 16th century, but it was only turned into a kind of proper sensor network when a Dutch scientist called Nicholas Crucius in the 18th century got access to the logbooks of the Dutch East India Company and kind of one of the great commercial fleets of the ages, and started building a map of magnetic declination across the world.
Right.
Therefore, kind of coming up with the idea of the dipole and showing that actually that the magnetic field was dependent on all sorts of varying factors. So, kind of a great kind of scientific advancement.
Yeah.
And built entirely on a sensor network.
So I guess your point is it's quite an interesting analogy to what is happening now. So let's say the East India Company were speculatively collecting all this data.
Yeah.
And then it was only sort of after the fact that Crucius came along and said, okay, well let's do something else. Let's map it and work out.
Of course, today data could be sent instantaneously from automatic compasses on ships, and that that information created by a computer.
But I think as well, I mean, the same with mobile phones. Obviously, you can get the data instantaneously, but again, there's all these. In fact, what's really nice is you don't need to ask people to go and get the data for you. It's just the sensors. One, I guess, big difference now is that there's no human involved, really. Well, the human is just carrying around the phone.
A gatekeeper. Yeah, the human is the gatekeeper of the sensors. Yeah.
But it's, you don't need someone to actually manually take any measurements.
Reduces human error. Yeah.
Reduces human error. Also, you can greatly increase the number of measurements you take because it just can happen automatically in the background. And you can obviously take measurements of things that humans can't measure.
And I think I think this is something that comes back kind of nicely to what we were talking about at the beginning, almost about sensors, about what is a sensor. And I always I know you've kind of called this in the past, but it's the idea that you take something which is kind of precisely unquantifiable to a person and make it quantifiable in a more advanced sensor. For instance, I can tell you it's a warm day, but I can't tell you it's 24.8 degrees. Yeah. And so even though what's nice about the more advanced sensors is that in the past, a human could use a sensor to a basic sensor to tell you that it was warm. That as sensors become more sophisticated, they allow for more effective relaying of data.
Well, I mean, humans basically
are sensors.
Humans are sensors.
I think we're getting carried away, James.
We're just not. In many ways, we're not as good as some mobile phones because we're disinclined.
Which is why it's great that we're all carrying around mobile phones.
Well, exactly.
Best of both worlds.
Exactly.
So shall we move on to I think it's a nice moment to talk about weather signal.
Yeah, so I guess weather signal you might see as the logical next step of the ship's logs.
Edmund Halley to us. That's what we're trying to say. Yeah.
Not a bad
route to go. Yeah.
So weather signal is an app that we've built that is using sensors on devices and trying to get any information that's relevant to weather. So
it's a meteorological sensor network.
Yeah,
I think.
So let's discuss some of the sensors that we're getting data from. We're getting data from light sensor, which is really common because
screen brightness.
Screen brightness is regulated by the light sensor generally. So your phone will boost its brightness outside. Because it's very there's much more. It's competing with the light of the sun. Indoors, it can lower its brightness and save battery, and you can still read it very easily. Right. So this is a great example of what I like to call sensor repurposing.
That's a great term.
So the sensor's on the device because it's doing something that's sort of core utility to the phone, or it's something that's kind of useful in a phone. But you can take that data and you can use it for so many other things. One of the things we're doing with weather signal, light's really important for just understanding whether the device is indoors or outdoors, because there's a massive difference in the...
a kind of unambiguous difference. It might seem like you're in a bright room, but actually a bright room is a kind of completely different to what a kind of shady day outside is.
I'll try and get the app up, but and we'll measure the brightness indoors, but it's probably going to be around
that'd be good to figure it out.
10 lux or something.
So
whereas outdoors, even when it's overcast, it'll be over 1,000. So you're looking, factor of 100.
So I mean, we've talked about pressure already, and this is what kind of drove us to build WeatherSignal. Was the knowledge that current weather forecasting is done from weather stations, which kind of offer cover kind of like. Oh yeah, that's
sorry, just interrupting.
Put it in front of my face. Go on. Will replace me with Atmos. Hang on, it's gone a bit.
A
bit dark. So as you can see, the current light in here is 88. Or no, it's changing.
So it's around that's under 100.
Under 100.
It's pretty good.
Yeah.
We've got pretty bright lights here in the office for our podcast.
Sure.
But it's as I was saying, like if it was day outside, it would be over 1,000.
Yeah. So yeah, as we were saying, kind of ambiguous. But yeah, so pressure is what led us to build WeatherSignal. So we thought, what happens? We now have access to this network of. There are billions of devices out there. Many of them. I think we recently estimated 300 million Android devices with a barometer in.
Yeah.
What happens if you can collect all that data and put it into forecasting models? And many forecasting models are done through what is called the Ensemble, which I didn't know before we got into this. The Ensemble method. I always thought, they collected some data and then they ran different models on it and tried to understand kind of what was going to happen, often very unreliably. But what I found that was fascinating was that they feel pretty confident in the models they have.
Right.
But the challenge is collecting reliable information about what the atmosphere is like right now.
Yeah, and so this is the Ensemble
Yeah.
is where you allow for little variations in your data, and weather systems are chaotic, literally,
Jinx.
or by the mathematical definition. I can't quote it for you, but they a very small difference in input conditions can lead to a very large difference in the development of the system.
So you take kind of multiple snapshots,
right,
or of the atmosphere.
Yeah.
And you put those into the model, and if they all kind of are greatly divergent, we don't really know what's going to happen. And if they all say, next week it'll be sunny, okay, next week will probably be sunny.
So you take a few different sort of best guesses of what the true conditions are, and then feed that through your model, and you see what you get out.
And that is why something like WeatherSignal can be incredibly important for forecasting, because what we are trying to do by replacing maybe 25 very incredibly well calibrated and effective weather stations, and really sophisticated sensors with 20 million, say, devices over the same area. Possibly a little optimistic, but we can dream.
We're at 50,000.
50,000 global, so hey, we're working on it. We hope to be able to collect such kind of accurate data as to be able to make the different, the many different snapshots put into the model, make them much more coherent, because we'll be more confident in their reliability.
Well, I mean, it's just kind of simple, more data, is better, I guess.
Well, I think that's an interesting point. I mean, people would say you've got phones in pockets, you have phones, in bags, and I know that doesn't really affect pressure.
Yeah.
Obviously pressure is useful because surface reading can give you a three-dimensional picture of the atmosphere. Atmospheric pressure is a measure of all the air above you and how heavy it is.
And it doesn't matter, and other great things, doesn't matter if it's in your bag or whatever.
But people say, a phone barometer, it's only in there to help your GPS positioning. It's not going to be as, there's a whole science going into calibrating these weather stations.
Sure.
How could this data possibly be useful?
Yeah, well, it certainly is, and I guess the key to understanding why is just how noise scales and how signal scales. So by signal, I mean sort of the
He's
true...
doing his Nate Silver impression on you right now.
I am. I don't know anything about how Nate Silver talks. I've read his book though, but so signal, we can think of as the true reading, or the influence of the true fact about the world. So the noise is sort of the perturbations of that because the device is not configured that well, or maybe you're upstairs,
or
different
different barometers. But different barometers are different. Yeah.
So what we found, actually, I want to give an example, not with pressure, but with temperature, where we've shown that actually, even with a very noisy data set, you can get a pretty reliable signal out. So we discovered that by using the battery temperature of Android devices, you can do a sort of small mathematical transformation and get out the outdoor air temperature. So let's make that clear. So let's suppose that this is one of the things we actually did. We published a paper on this, and we looked at several cities. For example, with London, we had several hundred devices each day sending various readings of their battery temperature.
Right.
Took an average over all those devices together, ran this very simple mathematical transformation. You can see it in the paper or on our blog. And we managed to extract the actual outdoor air temperature. And you think, well, that's magic.
Correlated against kind of historical record from external proof sets.
Yeah. So it's kind of simple because what happened was, you had all these different phones. Some readings would have been taken outside, some inside, some in bags, some in pockets.
Yet, despite that, you
could
still see the signal.
Yeah, exactly. Because when you think about from day to day, okay, all these phones are in loads of different situations, but sort of the situations they're in, like altogether, are basically the same every day. There'll be 10 readings that are taken in bags, or 100 readings that are taken like in pockets and so on. Yeah. And that stuff sort of is basically stable. That averages out.
Okay.
What changes from day to day is the signal. That's the outdoor air temperature. Because the indoor air temperature is fairly constant, the user behavior is fairly constant, the signal is the thing that's changing.
So if your data set is big enough, so this is big data at work.
Yeah, this is big data at work. This is kind of, I guess, older than big data.
We possibly couldn't have a podcast without saying big data at some point.
This is pre-big data in a way, because...
Do we have it on the... We don't have it on
it's just...
Big, you can't even see it on the screen. Right. It says big data up there. Anyway.
It's just a property of many types of data set that if you have some random noise around about a true mean, well, as you get more and more data points, sort of the amount of noise that there is squares is the square root of the size of your data set. This is maybe a little bit technical, but the actual sort of signal squares at size, the actual signal scales is the size of your data set. So, if you have 1,000 points, then your signal is 1,000x strong. But the size of the noise is root 1,000. Well, I should have chosen something much better than 1,000. But that's about 30x strong. So your signal is like 30 times greater than your noise. This is a very sort of conceptual way of thinking about it. Whereas if you take the data set like a lot down, and let's say you have only 10 data points, then your signal is 10x strong, and your noise is 3x strong, so it's only 3 times.
Right.
So you can see that as it gets larger, these are again, this is very conceptual. But
no, it's true. I think this is at the core of the kind of the new sensor network. The idea that more data is what matters rather than the cleanliness of the initial data.
Yeah, exactly. It's much easier. Let's think of it like this. Nowadays, I think it's much easier to collect more data than it is to collect cleaner data. So, it's very hard to say, okay, well, I want to get the very best sensor and put it into, 100 phones. It's actually a lot easier to build an app and say, okay, well, I know there's a million phones out there, and I'm going to build an app that's, useful to users, so it's going to get onto these million phones, and they're going to have some noisy sensors, but...
I think this brings us to a very good almost concluding point, which is, the mobile sensor network itself.
Yeah.
Which is that for the first time in human history, you have kind of covering the globe millions of always-on smart devices capable of collecting information from the world around you.
Yeah.
And one of the great barriers to doing sensor-based research, and there's a huge amount of research, and we've kind of briefly talked about a few examples earlier, and there are many more on our website, is the cost.
Yeah.
It comes down to economics. Setting up a network of sensors, of precise sensors that need to be maintained, regulated, and checked is enormously prohibitively expensive. With mobile sensor networks, the network's already in place.
Right.
We have hundreds of millions of devices with sensors that are capable of being repurposed for anything.
So I guess we're kind of coming full circle here, because we started with the oldest sensor network, which was...
built by consensus rather than... built by
a mandate.
A mandate, but meritocratically.
Yeah. So that was, the rain gauge. So the emperor's saying, you've got to... Everyone's in every province, we've got to have one of these. presumably logistically very difficult.
And I imagine there are lots of people who are furious about having the true value of their land being assessed correctly.
Yeah, I mean, no one's too keen on taxes. So, that's. But as you say, it was built. I'd say meritocratically in that someone
turned up and said,
"Right,
we should build this."
Yeah.
And happened to live in a society where that was A, permissible, and B, they were organised enough to put it into action.
Yeah.
So now you're getting to a stage where we have this same meritocracy. You know, anyone can build I say that I can't build an app, but anyone can build an app, I say, kind of diminishing your achievements. Anyone at all can build an app and put it on the App Store, and have people discover it, download it. I mean, obviously, it's difficult to kind of market. You need to get good SEO techniques. But theoretically, anyone can create an app that collects, say, pressure, as we do. They don't do that, we're doing that. Or anything from a mobile sensor, and suddenly have it on millions of phones worldwide, reducing the kind of the barrier to entry to almost nothing.
Yeah.
But I think what is interesting, I think this is the point that you made very nicely in the paper, is that rather than sensor networks being built by mandate. So rather than a developer going to the Prime Minister and saying put this on everyone's phones, or go to Google and saying put it on everyone's. Maybe that's the point I have to visit in a second. Is that now they'll be built by consensus?
Yeah,
people will either go, I love this app, it gives me great benefit, it's a really good game, it also does this cool stuff, I want it on my phone, or they'll say, I love this project to collect weather data, I should download this OpenSignal app.
That's the perfect place to conclude our first discussion on sensor networks. Just a call to action if you're interested in this and you don't yet have excellent apps built by very able developers. They are OpenSignal and WeatherSignal.
And I think, and if you want to read more about mobile sensor networks, as I mentioned, this paper James and I published is up on our website under opensignal.com/reports. Called Mobile Sensor Networks, Creating a Social Laboratory. So kind of check out, there's lots of great examples of really interesting other companies who are doing fantastic things in all sorts of different spaces using this technology. Cool. Brilliant.
Thanks.